go on the platform and what can't. We need to let the community provide that mechanism itself through its cooperative activity. We're also putting a bunch of AI agents onto this platform ourselves, which will include a lot of AI agents using the OpenCog toolkit that I talked about in my talk yesterday, and then deep neural nets, evolutionary learning, a lot of other things. So when we initially launch a scalable version of the SingularityNET platform, when we move from our current alpha to beta, it'll have a lot of our own AI algorithms and services on there using OpenCog, neural nets, evolutionary learning, and so forth. On the other hand, if we're successful, once the platform has been online for a year or two, our own AI will be a small percentage of what's on there, just as in the Android Play Store, Google has some very nice apps, but Google's apps are a small percentage of what's on offer there. So Cassio mentioned a few advanced aspects at the end of his talk. I just want to briefly review some of those. So he mentioned offer networks, and that somewhat has to do with, we're talking about the multiple dimensions of reputation. You can also look at this in terms of multiple dimensions of value, and using a one-dimensional token for exchange that's what we're used to from monetary systems, but it's not actually the only way to do it. So Dirk Helbling has written a bunch of papers on multi-dimensional money, where you could actually have a medium of exchange which is a vector, and we have that to some extent now. When you have food rated as sort of how, is it free range, is it organic, how environmentally sound was its production, is it fair trade? So there's a lot of ways you could rate value in multiple dimensions, and you also don't have to always exchange according to a quantitative amount. You can use barter. So I could say, well, I will classify 45 images for someone if some party, not necessarily the same one, will answer 20 questions for me, right? And so then you can say, well, I'll offer the network certain services if the network will offer certain services for me. And if many parties are posing these sort of offer request pairs, you can then use a constraint satisfaction algorithm to match them. And this is what's called an offer network. And Czar, who's sitting over there, wrote his master's thesis on the simulation of this sort of multi-party network and how to use constraint satisfaction to make it work. I don't think any of these is necessarily the golden answer. So what I'm envisioning is, like 5 years from now, a network like this will have a lot of one-dimensional token-based exchanges, which is how it was starting out, and probably different forms of multi-dimensional currency and multi-party barter. So I think just as reputation doesn't have to be one number, exchange doesn't have to be one number. And this can get pretty deep in terms of assignment of credit, because if you're looking at the payment as having to do with credit assignment, then credit doesn't have to be just one number either, right? So say you have multiple different reward functions, then these can correspond to multiple different dimensions in some multidimensional economic instruments. So there's a lot of subtlety there where the AI intersects with the economics when you look at the multiple dimensions of value. And another interesting aspect that Cassio briefly mentioned is using the AI in the network for analysis and verification of smart contracts. And if anyone's coded in Solidity, Ethereum smart contract scripting language, that's a powerful language. It's a Turing-complete language. It's more powerful language than is really needed for the smart contracts that are currently out there. And the additional power is sometimes used to create weird bugs that make smart contracts work in ways that the creators did not intend. So I think a more sound way to do things would probably be to write smart contracts in a somewhat more restricted language, which could be a subset of Solidity or WebAssembly, or it could be in domain-specific languages, like for smart contracts for e-commerce, or smart contracts for law or something. And then, being in a slightly more restricted language, the smart contracts can be turned into predicate logic type formulations, which could then be analyzed in a logic engine, which could be OpenCog's PLN logic engine or a different logic engine. You could then check them for bugs, you could verify they have certain properties, you could simulate how they behave under certain scenarios. So I think this is an AI application in which some of the AI in the network could actually help the network functionality to be good by checking the smart contracts involved in this network and also in other networks. And if the blockchain evangelists are correct, then more and more of the economy will be running on smart contracts, and that will be supplying business logic underlying various different industry sectors, which is a different question than whether cryptocurrency become a popular medium of exchange. If blockchain and associated smart contracts become pervasive in industry, then having a good way to do formal verification of these smart contracts becomes highly valuable, because these are, by their nature, they're programs that are being used to transact huge amounts of money and large amounts of goods and services. And that's like a beautiful textbook case for formal verification. And that requires AI to be used in a certain way, and it also probably requires more discipline on the part of smart contract programmers and language designers. And then the final piece I wanted to mention gets more to the AI side, which is, on one of his final slides, Cassio mentioned the ability of AIs in the SingularityNET platform to outsource work to other AIs. And to me, this was actually the feature that made me want to do this project in the first place. Because making an app store for AIs, it's certainly interesting, and having infrastructure as a service for OpenCog and the other AIs I'm working on is going to be awesome, right? Because I mean, in the OpenCog team, we're working on inference, meta learning, and integrating neural nets with reasoning and various language processing, language learning. We're really not, from an OpenCog standpoint, wanting to think about scalable deployment and marshaling resources automatically and persisting things and backing things up when they fail. But we need that infrastructure. So to the extent you can have really slick infrastructure as a service provided for AI development, that's interesting. On the other hand, what really made me see profound potential here is the idea that you can have a network of AIs where AIs are submitting queries and requests to other AIs, outsourcing work to other AIs in a complex network. Because what that means is the network of AIs, in essence, becomes the AI. It becomes the meta AI. And then the token, or the multidimensional token, or the barter network exchanging value in this network becomes what turns that society of minds into an economy of minds. And the reputation system is key here also, right? So you have an AI that pays another one for its services. You have an AI that says, well, this service is a good trade for that one. And you have another AI that says, well, don't trust that guy. He said he's going to trade A for B, but he's not really going to do A, right? And all these mechanisms enable the whole network to interoperate effectively. And I want to run through in just a minute a few concrete examples of how AIs outsourcing to other AIs may be interesting, which are specific things that either we're working on now or I would like to work on the next year or so. So one example is you have evolutionary learning, and in some cases either the fitness estimator or the fitness function could be a whole different agent, which could be written by someone else, and it might even be proprietary code. So for example, I've been talking to Christian Schaffmeister at Temple University about using evolutionary learning, like OpenCog's Moses tool, to basically learn new molecular designs using spiral ligament molecules. So we're trying to design new enzymes. So genetic programming, the genome is a series of steps for creating a new enzyme by putting certain types of molecules together. But how do you estimate the fitness? I mean, actually building the molecule in the lab is expensive, right? So you run a molecular dynamics simulator to estimate the fitness. Now, if you're doing a SingularityNET type design, I mean, you can have your Moses GP type system over here. Oh, that marker doesn't work. You have your Moses GP type system over here, which is evolving new molecular design, and then there's a molecular dynamics simulator over here. And the nice thing with this kind of framework is, I mean, there are many molecular dynamics simulators in the world, right? And so this GP system could outsource fitness evaluation to this molecular dynamics simulator, or if that one makes a lot of mistakes, it'll get a lower reputation. It'll start outsourcing work to a different molecular dynamics simulator. And there could also be an inference engine, which in some cases, the molecular dynamics simulator may run too long, so you could have a PLN, say, logic inference engine, which sometimes does fitness estimation and guesses the effectiveness of a certain configuration of molecules. Then you don't need to run the molecular dynamics simulator. But the architecture this sort of system leads to is, okay, it's not monolithic. You can have the molecular structure evolver here, and then there can be many different agents which serve to do fitness evaluation. So I mean, ultimately it can be a different way of thinking about creating and designing an AI system. I mean, there's been a difference in my lifetime as a developer where when I started programming, if I wanted a tree or a hash table, I would code that, right? And then, of course, that's completely shifted in the last, 35 years since I wrote my first code. Now you never write a data structure, you're using a library, right? So this is a little different. It's beyond using a library. You're saying in real time, I'm going to dynamically consult another agent and not just use a code library. And of course, that's not a new idea to SingularityNET. What's new here is the interleaving of this with a decentralized implementation, reputation system, and then an easy-to-use payment mechanism. But from an AI view, if we had a rich, flourishing network of AIs interacting according to a diverse set of APIs, it would mean you could focus on the particular part that you wanted to build, say a new way of doing evolutionary learning, and then the rest is carried out by an assemblage of different agents that can be paid in real time for helping. So I mean, another example would be you can use neural networks to approximate the fitness function. So maybe after you run the molecular dynamics simulator enough times, then you can use a deep neural net to simulate the output the molecular dynamics simulator is going to give, right? Well, that would be a different agent, which is a neural net simulator, right? And I mean, that's been done for simulating Newtonian physics engines and game engines. No one's done it yet for molecular dynamics simulators, but it will be the same process. So another example where the ability to outsource work should be useful is in our work with probabilistic logic. It has occurred that a lot of the reasoning steps that we need to do are really straightforward theorem-proving steps, like crisp reasoning steps. So you could have a heuristic probabilistic logic engine, which when it encounters a premise that looks like it can be solved just by crisp predicate logic theorem proving, it could outsource that particular inference step to a crisp reasoning engine. And then this becomes, obviously you need quite high bandwidth interactions here. Those guys have got to be living in the same server farm, right? But you could have a PLN probabilistic logic engine here, and you have a crisp theorem prover over here, and I mean you could have a simple, very large Bayes-net estimator here, and as this guy is doing some logical reasoning, say it's doing backward chaining inference, if it comes up with a predicate it needs to estimate the truth value of, sometimes it can do its own work, sometimes it can outsource that to some other logic engine, right? And that if things are fast enough, that means that the answer to a natural language question or a scientific hypothesis, I mean, that could be resolved by a backward chaining process where different parts of the tree were actually fulfilled by different agents living in the distributed network. And as Cassio pointed out, all this stuff occurs off-chain, where the blockchain is involved is in the identities of these agents exchanging each other's addresses when they start off the interaction, and then knowing each other's reputation, so they know they want to trust each other to help help answer sub-questions for each other. But once the initial relationship of trust and the IP addresses and everything is worked out, then you can send a lot of information back and forth without worrying about the blockchain. Things can be quite rapid, assuming things are co-located. So the final aspect I want to highlight has to do with data, and we're working with a project called Shivam, which is sort of like 23andMe on the blockchain. So the idea there is if you like upload your DNA, if you've got your DNA sequence, you can upload your DNA data. It's encrypted. Then if you want to supply that DNA to someone for AI analytics, then you can choose to opt in to supplying your DNA for someone to use for some particular purpose. And it can also be encrypted using homomorphic encryption or obscured using multi-party computation. So they can't even, if they're using your DNA to analyze the genetic roots of diabetes or something, then they don't necessarily have to be able to see all aspects of your DNA to be able to do that. And that's a different aspect. So you may have an AI, this AI process is just using basic molecular information, but if you're using something here to analyze DNA data, right, then this is accessing you can use Moses genetic programming again, and it needs DNA data to do some of the work that it's doing. Well, where does it get this DNA data? It may get that DNA data from some particular people who have uploaded their data into nodes in the SingularityNET, and then a request is made, and that person may manually, through user interface, decide to supply their data to this process, or they may have made some automatic rule, like if a request comes from a verified nonprofit medical foundation, then say yes and supply the data if the reputation of that foundation is high enough. And then in some cases data may be supplied for free. In some cases the user may be compensated with some tokens which they can then cash into another currency. So it could be a pure research thing, or if it were a for-profit medical research company doing this, then they paid something to have this analytics done on data, then some of that payment can go back to the people supplying the data. And DNA data is an aspect that would interest me, but you can imagine a lot of other cases. Like we're always supplying all this voice data to our phones. What if we were saving that voice data in a file on the cloud, encrypted, and then if someone wanted to use that voice data to train a speech-to-text model, right, then we would get some compensation back and possibly money, possibly free use of that speech-to-text tool in exchange for our data. So there's the ability to have processes outsourced to other processes has a lot of different aspects. I've just highlighted a couple of them now. We could go on a long time for this, but that's the platform and the reputation system are key parts of the infrastructure needed to support a robust network of AIs cooperating, outsourcing work to other AIs, and then the hopeful outcome of this is a sort of metamind formed from a bunch of different AIs. And I don't think that, it doesn't eliminate the need to have some AI agents that can actually do robust generalization and learning and abstraction. Like there has to be transfer learning and generalization and self-modeling and all that good stuff inside some of the agents. Just like you need the whole body, but there still has to be abstraction somewhere in your cortex, right? But having this framework can enable this core code doing AI generalization to have a lot of impact in a lot of different areas. And that's more than I had time for. So.